just in time for the holidays here, we have a couple of new RF products to showcase for you. So the first is going to be our 1 millimeter series, and the second is called our POM2 series, both of which will be presented by Mr. Mark Waring. So Mark, without further ado, sir, can you please enlighten us about these new RF products? Thank you.
Thanks, Pete. You can hear me, I guess. And yeah.
Yes, sir.
Okay, great. Yeah, I'll jump right into these. The one good news is these are going to be more like 20 minutes combined total, so they're pretty straightforward introductions. So we'll get you guys finished a little earlier than the schedule says. The first one is the 1.0 millimeter test port. Hopefully some or most of you have seen this sort of generic slide that we use to show our Hirose family of RF products. And where does this first new NPI show up? Well, very cleanly, it shows up right in an important series, which again is our various test and measurement connectors. And let me just describe what those mean, and then I'll introduce the new product. These are de facto industry standards where we have competitors selling drop-in replacements, or you could say we sell drop-in replacements for other competitors. They go by numbers primarily, which denote the frequency bands that they support. 2.92 millimeter connectors support up to 40 gigahertz, 2.4 millimeter connectors up to 50 gigahertz, and 1.85 millimeter connectors support up to 67 gigahertz. They also sometimes go by the traditional names that were given to these frequency bands decades ago, like K for Hyper or Keeper, whichever you prefer, and V for, I forget what it meant, came from. But anyways, you will see those letters used by some of our competitors, and we use them as well for some of our part numbers for these things. So where are these current connectors that we've already been selling? Where do they go? You know, what kind of customer usage do we see? Well, again, they're called test port connectors for a reason. They don't solder onto anything. They don't firmly, ruggedly attach to anything. They're held down by tiny little screws that come up through a printed circuit board and into the threaded sockets on the flange, which you can see in the upper left there on both our vertical types and edge launch or horizontal types of these connectors. So these are used mainly in test or eval boards internally, although some big chip companies definitely produce these in higher volume, and they give or sell these downstream to their business-to-business customers who need to do further evaluation of whatever's on the board. Again, typically that would be like a high-frequency RF chip package that they're trying to evaluate. Another big family of applications for these types of connectors are on photonics test boards. Photonics optical transceiver test boards, even more specifically, where all of those products have to go through compliance board testing, where they're going to have a board just like what I'm showing here with 16 or 32 of these expensive connectors on them. So there are lots of good opportunities out there. We have some big customers who've been great repeat customers for us for many years on these. And the other nice thing about these NPI, and it sort of fits into what I'm already saying, is that Hirose is already a very trusted and recognized supplier. So, some NPIs, right, suppliers trying to break into some new customers that really don't know us very well. But in this case, the customer base we'd be going after are ones who are probably very familiar with Hirose, and I think for the most part are very happy with Hirose as a supplier to these types of products. And that's always a big foot in the door for trying to introduce something new. And so here's the new product, which is just, again, a pretty logical extension. And this is the next industry de facto standard. So we didn't make this 1.0 millimeter up. There's about 2 or 3, probably 4 at least, tier 1 suppliers that already have this product out there. Ours is fully released. We've been showing it to some of our lead customers who are already using these other Hirose connectors I just talked about. We already have strong interest from a couple of those biggest accounts. Another has come to us and even heard about it on their own. So, there's some market pull, I guess, is one way to say this, which is always nice to see that there's actual interest and an actual need for this as frequency trends just keep going up. And these are driven not only by, I should say, analog RF, eval boards and optical types of test boards, but even digital differential signaling boards that are doing evaluations of FPGA, GPU, networking chip types of solutions. They often are going to be doing breakout boards where they want to be able to get in and see what the signal looks like. And these would be the types of connectors they're using to get off of that to a VNA or a digital oscilloscope. So again, the 1.0 millimeters is just what it sounds like. It's a very small connector if you hold it in the palm of your hand. But it's not a small price-wise. These things get more expensive sort of exponentially as you go up in frequency. And because this is sort of bleeding edge, the market pricing, including ours, is going to be at a disti level over $400, believe it or not, per connector. So that's a big ASP, and it's attractive, obviously, from a sales standpoint. You don't need to sell too many of these to equate to selling many thousands of our typical little micro connectors, right, which go to 15 cents or something very small like that. So this is an entirely different animal. Another nice point about going after business with this and any of these types of connectors is the time from conversation to purchase order can be very short. So unlike a consumer or a medical product or something of that nature that might take months or even a year or more before you're going to see the revenue, these are often quick builds that engineers need to have. And if you've got the right product at the right price and the right support, again, you very possibly can see POs come into your inbox very quickly. So that's another, I think, nice benefit from a sales perspective for these types of products in general. Here's a very simple one pager. The graphs that are down the bottom are what engineers care about. VSWR is the most important. It's the standing wave ratio, or how noisy or unnoisy, hopefully, our connectors pass these high frequency signals. Without going into details, we have a tier 1 level of performance completely on par with anybody else. It's hard for any supplier to show distinctly better. You really just, you want to be not bad is the goal, and we're definitely not bad, and we're just as good as probably any of the other tier 1 suppliers out there for these VSWR numbers. So that's not an obstacle for selling this product. And here's a little bit more sort of elevator pitch, but these are legitimate value add, comments that, can resonate with different types of customers, whether it's an engineer or a purchasing manager you're talking to. A lot of our competitors do have a very vertically, narrowly integrated supply chain that may be third-party contract based as well. We're doing all of our builds in-house at Hirose factories in Japan for this stuff. We definitely have, better than even other tier 1 North American suppliers, local technical expertise with a local hire signal integrity engineering team here in San Jose where I work. They can really roll up their sleeves and walk the walk with helping customers, big or small customers, do things like optimize their PCB design, details like side plating effects, stack up materials, ground via pattern optimization. And they can do simulations of these as well for the customers with their own boards and give them feedback before they finalize their design. Some of our suppliers have a very narrow distribution channel too. Some of them don't use a lot of you guys and disti land. They use their own little boutique or niche kind of disti. So that's another benefit that Hirose brings, is that we have a very robust number of distribution partners. I think he had corrected me. He said it was 8, not 9. But anyways, we've got a lot. So, at the bottom is sort of the challenge to give to the customer, give Hirose a chance. If you're not already using us, let us show you how we can really step up and be a great partner. And that's really, we actually can do that in these cases for these types of connectors. We prove that every year with keeping some of our biggest customers happy and coming back to us for more business. So in summary, this is just a pretty straightforward extension of a series or a family of series that we've been supporting for a long time. It's an important one. It's a de facto industry standard for the next highest frequency capabilities. There's a definite need for this type of solution out there in the market. I would even say a strong need for it today. So take advantage of the fact that Hirose is a recognized name here, that we are price competitive. I will say that these are sort of nosebleed, early adopter types of products still. So there's definitely already a price waterfall effect sort of taking place, and we will probably, I'd say it's very likely we'll need to re-examine our own Hirose cost and price structure in the future on these. So any feedback on that regard is always helpful too. But again, there is pull for this. And what types of, again, just to repeat, what types of customers would be doing this? Anybody who's doing a high frequency RFICs, or supporting componentry or system builds around high frequency RFICs, customers doing more communication, which could be in 5G, it could be in proprietary aerospace communication fields, test and measurement equipment. They're going to be doing a lot of eval boards as well. LiDARs and other high frequency ADAS or automotive standard or technology that requires high frequency boards. Anything regarding that. And again, optical transceiver, or more generally optical networking and evaluation boards are all opportunities for customers who likely are using these types of connectors for their own use, and maybe even downstream supplying boards for some of their business-to-business customers. And if you're looking up, and I realized I didn't really clearly put the name to look it up. If you want to look up this part, just go to the hirose.com and type in H1.0. And then you'll see a couple of the products there that we have. And it's just this one single vertical type. We are already looking at a horizontal edge launch, but these are very delicate little devices, and the customers that we're talking to so far are leaning towards using these vertical types. So I think we're hitting the right landing pad for this initial product, but we will definitely probably see additional versions of this connector going forward. And let me just jump into the second, and we'll definitely have time for any Q&A at the end for either of these products. The next product is a little more niche-y, a little more proprietary than the first, and actually, so it's a little simpler even to introduce. It looks like some of our other industry standards like MMCX or SMPM, if you're into RF standards. Those are other connectors that we sell that look somewhat like these. They're slide-on connectors. They're sort of brass coated. They're nice. If you hold these in your hand, they've got a nice heavy little solid feel to them. They're certainly not as cheap as some other options, although they're nowhere in the $400 price point that I talked about on that 1.0. But these were designed for some specific applications. These work up to about 6 gigahertz, as it says in the title. And so the type of infrastructure that would probably be the number one target for this would be 5G communication industry. And that could be integrators, Nokia, Ericsson, whoever, doing small cell, doing base stations for 5G sub-6 infrastructure. 5G, of course, you're familiar with, and 5G is broken into 2 frequency families. One is called sub-6, and it means it's sub-6 gigahertz. The other is called millimeter wave, and it starts at about 28 gigahertz. So these are a perfect fit, and this is what this was designed for. Some big Asian OEM customers actually who had a need for this. This can be used in 2 configurations. First, a board-to-board configuration. It's a 3-piece solution with 2 receptacles that mount to 2 printed circuit boards, and a vertical interposer, which sandwiches in between the 2. And there's 2 different types of the board mounts. One is, we call it a locking version, and that's probably right here on the left. The next we call we call it without locking, but we also mention it as sort of a floating version because it allows this interposer, when they're all stacked up, to tilt left and right. And so you get a floating or a misalignment mitigation effect by using specifically this second receptacle. And you could use them in combination. You could use the locking version, the rigid locking version on one PCB, and then on the other mating side, you might customer might very well want to choose to have that unlocking or semi-floating capable receptacle on the other board. Now going back up to the slide before, the other configuration that's supported is a board to cable configuration, and that specifically targets having a SMA jack on the other end of the cable, and I'll show you why. And that was Hirose's choice as our first instantiation of the board to wire to have the SMA. I'll show you that right well, in a slide or so. This is, again, similar flyer type of slide for this new part. It is showing the misalignment capability here and showing good signal integrity for a range of misalignment between the top board and the bottom board. So this is sort of engineering details that can be important to customers who are interested in using it for that capability. And again, I do have the part numbers called out here, as well as here, of course. So this one's very clear, and you can already find on the Hirose website as well. This is a real world design win with this product. And I'm sorry, it's a little fuzzy picture. This is an large Asian telecom communications company customer. The little gold nuggets you can see at the ends of those looped black cables, those are this product. And in this case, they are the right side instantiation. So it is the board to wire version that this customer chose to use. And this is a good picture, although it's fuzzy again, to describe why the SMA is a logical choice to put on the other end. And on the bottom, it's very clearly shown in the little mock-up. It's a screw-on rubberized SMA antenna. So that's how it works. And that's a very typical industry application solution for a sub-6 antenna would be a simple SMA screw-on type of, in this case, probably weatherized type of SMA antenna. And that could be upgraded or swapped out in the field because the SMA is just a screw-on, a simple, secure screw-on type of solution. So this is an example for a 5G sub-6 base station specific or small cell application. And it's a great example of the type of customer and the type of product where you might find some interest in this particular product. So to summarize this one, it's a fully released product. It's a proprietary design. It's not an industry de facto standard. This is a Hirose one-off solution, which might meet some customer specific needs. Expo, pleased to make sure include this on anybody who's working on these types of 5G networking proprietary RF communication radios. And I think I made a typo there. I was probably copying slides. It should say, please make sure to include this new POM2 solution. So we're still talking about the POM2, but everything else is correct on this slide. So with that, thank you. If there's any questions on either of those products, let me know. Oh, those are already loaded on several of your disti websites, but none of you have stock yet. And I know that we're planning an NPI, a full NPI, which means giving stocking order suggestions to all of our distis for the 1.0 millimeter shortly. But that's not an obstacle to going after business. We have inventory in Japan. You have it the distis have it on their systems. These can be ordered immediately, and we can get small quantities almost immediately to interested customers and follow that up with purchase orders, of course, and planning for shipping in whatever quantities required.